Okay, so this is really the periodic table chapter. So lots of time spent looking at the periodic table. So a lot of girlfriend, boyfriend time. Just, quality time so you can get some quantity, or quantity time so you can get some quality time. Okay, so I'm not going to spend a ton. I mean, this first part is just more introductory stuff. But you guys saw last chapter how much information is on that periodic table. A lot of stuff you had no idea that it was arranged the way that it was arranged. You had no idea that you had your S blocks, your P blocks, and all that stuff. There's a lot of stuff packed into that, and we haven't even talked about the colors. We haven't even talked about the location. We haven't talked about all kinds of different things that are on there.
It's a pretty rainbow.
Okay. All right. So periodic table of elements, a table of chemical elements arranged to display their periodic properties in relation to their atomic numbers. Does anybody know what periodic means?
Order.
Repeatable. Okay? Now, it organizes the essential information in a manageable format. I would say once we realize how to look at that periodic table and realize the format it's in, it's pretty easy to follow once you understand the format it's in. Okay? So the very, very first person to really start coming up with anything that remotely resembled the periodic table was a guy by the name of Antoine Lavoisier. He's a French guy that is also known for coming up with one of the gas laws that we'll talk about next semester, I believe. Okay? So he published a list of elements. His first list of elements had 30 elements, or what he said was 30 elements. But we know now that his list of 30 elements that he came up with were mostly compounds containing oxygen. So what he thought to be elements weren't elements. Most of them were just common compounds that contained oxygen, like water and CO2 and oxygen gas, things like that. They weren't just lone elements. Okay? So he really started the process of trying to organize these elements in a particular way, because at this point we're progressing fairly well in our identification of the atom. And so they're trying to find a way to organize this. So he started, but he kind of was a little bit off. Okay? And then came another guy named Johann Dobereiner. Remember that guy?
Yep.
It's a no-brainer, right? If you remember from physical science, what he did is he was really the first scientist to start arranging them in a particular system. Now, do you guys remember what the system was that he arranged these guys in?
Atomic mass.
Atomic mass. Which was actually a fairly good way of doing it, because as you add protons, your mass is going to get bigger, right? So the relationship between the atomic mass order and the atomic number order is pretty similar, except for one little thing: neutrons. Okay? Because neutrons can change, there might be some elements that, because they have more neutrons, end up having more mass, even though they have less what? Less protons. Okay, and the two most notable ones are, where are we? Right here. Okay? Selenium has 52 protons and an atomic mass of 127. Iodine has less overall mass, even though it has one more proton. So what does that tell you about selenium's number of neutrons? It's got more. What?
Yeah, but it's 127 to 126.9.
It's not much difference, but enough that his atomic mass arrangement would be false, right? Would not have been arranged due to chemical properties. You with me, brother?
Yep.
Okay. He was also the first guy to come up with triads, or notice things that had similar chemical and physical properties. So if you look at these guys, these are part of your halogen group: chlorine, bromine, iodine. They had very similar chemical properties, so we started to group them based on similar properties. Okay? Bright, very colorful, had a lot of very, very similar things. These guys all react very, very rapidly and very, very readily. Okay? So he was able to kind of start grouping them. If it were me, I'd probably give Dobereiner at least some credit in our modern periodic table. However, he's not the guy that gets all the credit. You guys remember the guy that gets all the credit?
Mendeleev,
Mr. Dimitri. Okay, I'm going to name my next son Dimitri and my following son Quantum. Dimitri Kramer and Quantum Kramer. Don't you think that's an awesome name?
It's a bit Russian.
No.
Hey, Quan.
Hey, Quan.
Hey, Quan.
Hit the Quan.
Hit the corn.
That was beautiful.
Not be good.
Coming from a bunch of nice Christian school students.
I'm just saying, look out for your kid's future.
So Dmitry Mendeleev, he was the guy that was really given credit for coming up with our modern periodic table, but he still had a really big problem. What was his problem? Anybody know?
Let's see.
I don't remember.
Turn to page 106 in your books.
Okay.
Okay? Here's his big problem. Mr. Dmitri still arranged them how?
By atomic.
So he still arranged them by atomic mass. Okay? Because he arranged them by atomic mass, still didn't have that part right. The reason why he's given credit for discovering our modern periodic table is this. If you look at his table there at the bottom, okay, notice he left some what?
Spaces.
Spaces. He was seeing a trend that certain things would jump. You essentially had gaps where, for example, let's look here. You got zinc at 65, and then you see a pretty big jump to AS 75. So what he assumed is there was some unidentified elements that had yet to be discovered, and a lot of those spaces got discovered later, thus kind of proving his theory correct. Okay, if you look, a lot of these guys, for example, atomic mass 68. We got an atomic mass 68 up here, approximately. Gallium, wouldn't that be right after zinc? Everybody see it? And then 72, germanium, and then what? Here were his two elements, here were his two unknowns, they discovered them later. Okay, so that was, I could get why they give him credit for discovering the periodic table, because he really did predict a lot of things. Okay? It actually wasn't until Henry Moseley came along through some experimental stuff where they started counting the protons of the atoms that they realized the better way to arrange Dimitri's list was to do what? Arrange them by atomic number or by the number of protons they have. So we've got Lavoisier that started the whole idea of trying to list, even though he most of his list was what? What was most of his list? Most of his list, I talked about. What was in his list? Compounds. And they weren't elements at all. Most of them were compounds with oxygen in them. Okay? Then along came Dobereiner, who started to arrange them by a certain way, atomic mass, started to see some groups that acted very similar. Do you remember what he called those groups? Groups of three, triads. Okay? Then comes along Mendeleev, who is credited with coming up with the periodic table. And the reason why he's credited with coming up with the periodic table is because he predicted some unknown elements that were later discovered. But his periodic table is still arranged how? Atomic mass, which is not correct. Okay, then comes Moseley. They discover counting protons. They figure out the best way to arrange it is by increasing atomic number, and so forth. So then we get our periodic law, which simply says, since periodic is repeatable, it just says that the properties of the elements in our periodic table, if we arrange them by atomic mass, okay, they vary in a very repeatable way. Okay? And I think this is the last one, right? This is just one of those Small vocab words that could very well come up on your fill in the blank section on the test. There's a lot of these vocab. Transuranium, which is simply all the elements after uranium.
So the green one is supposed to come.
Okay? So uranium 92 here. Your transuranium elements are the elements that come after uranium, which most of them are going to be your man-made elements or your nuclear radioactive ones. Okay? And you can only find trace amounts of 2 of them naturally in nature. The rest are so radioactive that they get created and poof, gone.
So naturally in nature.
Okay. That's it for today.
Why you consider them to be don't stay.
Wait this up.